Where did you go from there?
Phew, there was always a parallel channel for technology development. These companies were not technology creators and innovators and developers so much as purveyors of product and profit. So there was always a backstream of developing stuff.
Within the company, or was that separate from you?
No, that's outside the companies. In a lot of cases, I used to identify it to the company and say, these are my declared areas, because you're coming up with intellectual property and you want to make sure you're not competing with them or that they're not getting upset that you're going outside your employment arrangements. So you go to them and say, well, I'm doing this and this. And they say, oh, that's fine, as long as you declare it. So there was a bit of that going on. And so at the end of that, it got to the point where the technologies that I'd done in the audio field had got to the point of being able to be productized. So you have technology has to be created and matured, encouraged, and then put into products, and then products need to be taken forward towards market and so on. So a lot of the early products were about ready to be assembled. So I put up a few shingles and got a few mates together. I think they got me together and I got them together, and we started designing and making audio equipment.
It sounds like you had experience that was leading to this development. You started out with a skill base, obviously. You then moved into manufacturing, your experience with Telecom and Telstra. Then you moved into technology, marketing and market development. And then you started developing products that put all of those things together into creating a new product. Would that be a reasonable summary?
There's a bit missing.
What's that?
Before you actually create a product, you've got to create the technologies. And that is an area that is not necessarily understood. A lot of these product developments are basically integration. You're not developing a new tech. I'll try and give you an example while I'm frantically thinking of it, but you say, well, I've got a platform of technology, or I've got a platform of manufacturing capability, but those are all existing. You haven't created those. They're there, and you're just integrating it and getting it out to market, and your main concerns then are channel to market and deliveries and warehousing and that sort of stuff. But in the case of the true startup, the mass acoustic startup, you're actually creating the technology before you package it up. And that was some of the issues that we had with the new acoustics work, which you came up with the idea, you analysed it, you either scrapped it because it didn't work, or you scratched your head and said, oh yeah, this will work, and you got it to work, and you produced a bit of software and programs to model it, and it seemed to be okay. And then you've got to start on the process of, well, how do we package this? What do we put this into?
Let's go back a step. How did you come up with the ideas in the first place?
Good question. It always just seemed logical to me. People see a passing parade of products. They don't necessarily think about how or where or when those products came from. So the example I've given is you buy yourself a rose plant and it's susceptible to black spot or mildew or some other dreaded disease, and so you don't buy it. But has anybody ever asked why that particular species is susceptible to that and that other species isn't susceptible? And surprisingly, the answer often is no. They just know that if they select that product or that rose, it doesn't have that problem that one does, so we won't have that one. So we forego the benefits of some of the rather beautiful ancient perfumed roses. In the case of the technologies, it's a similar sort of thing. You come up with a technology approach and you just take that. You don't necessarily question what's behind that. But I used to question what's behind that. You know, there's an interface between your ears and the thing that's making a noise, and that's called you might call it the transmission medium, but most people would call it air. That is just totally ignored. Nobody thinks about the fact that there is a complete level of delivery between you and the thing that makes a noise. And then you say, well, how does that work? And so you have to go through the process of analysing that. And then, well, let's go to the next step. How will we synthesise a better way of doing that? Not necessarily in terms of the device that made the noise. You need that. And I did, and I still do work on that. But how does it get to you? And what influence does the room have? And can you control that? Can you manage that as part of a delivery process? Similar sort of thing. Nobody worries about it. They just say, oh, we'll get another room.
That's not always the answer. And your 3D stereophony seems to go down that path.
Looking at how waves propagate. And in parallel with all of that, telecommunications, let's get it back into the audio and acoustics side.
It's the telecommunications and transmission line theory that underpin that. You have an understanding of that from your telecommunications experience.
You did, but very, very simply. And I could probably say that heavy side would have been probably horrified, but the initial stuff that I did with Greg Cambrell was very simple. It was just like a pipe full of air that was like a transmission line for electrical signals. It was just a guided media. And then all of the theory of transmission lines for their stability and their power reflection and transmission and their attenuation, all of that could be stolen, I suppose, but could be applied to guided media. So here we have a structure and we'd like sound to go in one end of it and we'd like sound to come in at the other end of it. How do we shape that structure so that we get the right efficiency, bandwidth, velocity, pressure, whatever parameter it is? How do we do that? And it just, to myself and to Greg, it just seemed obvious.
But that's your mathematical background coming out.
It seemed like it, to me, it all just seemed obvious. And I've learned that it isn't, but it just seemed obvious. So you'd say, well, why can't we change these devices so that we get the desired transfer function, whether it's efficiency or bandwidth or whatever? How can we get energy from this thing to this thing in the best way? But we're not talking about a loudspeaker necessarily. We're talking about the stuff in between called waves. And waves are just things that propagate through a medium. So the theory that we had for speaker boxes was also applicable to ultrasonics. And it was also applicable to seismic technologies and areas of seismology and other aspects. All of it based on, well, it's a wave, it's propagating, and it's found a discontinuity. What's it going to do? How does it react to that? And it's got lost. And yeah, that was a core thing. And maybe the difficulty was that if you just assume that there isn't anything between you and a sound source, then you don't realise that you need to analyse and work on that particular part. So to me, the loudspeaker box was just part of that process. And the coupling into the room was another part of that process. But the room itself was part of that process. So we were able to say, well, let's get a solver going, and we unashamedly pinched it all from the Berkeley SPICE solvers, which would invert the solution to what would be a difficult problem. And we could perform an analysis that gave you a source and everything in between. And I mean a source in the electrical sense. So part of what was in between was a magnet and a speaker with a coil of wire in it, or an electrostatic transducer. And part of it was a cabinet, and part of it was a transmission duct, and part of it was a room, and part of it was your ear, the whole thing.
The evolution then is starting from Beranek in the 1940s and continuing through to your design that included the head as part of the process.
I've been very, very privileged, and people say, oh, you're just saying that, but it's true. I've been privileged. You get up with your crazy theories and you talk, and you're quite happy for somebody to come on and say, nah, that's complete rubbish, or, oh, have you thought about this? And I've been very lucky because I didn't work with Leo Beranek, but I worked with Neville. And I worked very, very peripherally with Doug Lampart before he passed away. So I was very lucky to have people who weren't closed to new ideas, but were very capable in their own fields. And so we were building a better model. I was taking what they'd done and putting a little bit on top in the spot, and they were adding a bit. And so we were building up a better view of how things actually work. We haven't fully solved that. People say, oh no, it's all done now, you know. Everything that can be patented is being patented. It's not true.